Alright, so we're going to finish up section 14.4 here, the tangent problem and derivative. I'll start off with example number 1, where again we want to use the difference quotient to find a function for the derivative of the function f of x equals 2x squared plus x. Okay, so again, why don't you go ahead and pause the video and see if you can do this one again on your own. Right, then you're using the difference quotient specifically to find a function for the derivative. Alright, so here we're back, again using the difference quotient method. So we'll call difference quotient method of finding derivative in the limit as h goes to 0, with the function defined at x plus h minus the function defined at x, all over h. Okay, so again, we're going to take this 2x squared plus x function and plug x plus h in for x. So here we have 2 parentheses x plus h parentheses squared plus x plus h. Again, we're plugging in for x's the x plus h. And then we're going to subtract the function as is. So here subtracting 2x squared plus x. And again, that's all over h. Okay, so we got to simplify here, so I'm going to evaluate this right here. So we showed you all the work again over on this side. So you got to square x plus h first, then distribute the 2 to get that part, and then here's the x plus h. So I brought that all over here. So all of that is this, and we're going to subtract the function as is. So here it is, minus 2x squared minus x. And that's after distributing the negative. Alright, so we're going to simplify here. So I got a 2x squared and negative 2x squared cancels. This positive x and this negative x cancel. So now we're left with these terms right here with h's. So since they have a common factor of h in all three, I'm going to go ahead and use this h in the denominator to cancel or reduce. So I'm going to be left with 4x plus 2h plus 1. Alright, again, it's plugging h, factoring and dividing each of these terms by h. I'm left with 4x plus 2h plus 1. Alright, so now we're going to evaluate this limit of this function as h goes to 0. So plugging 0 in for h, I've got 4x plus 1. Right, plugging 0 in for h, I'm left with 4x plus 1. Alright, so here is the derivative of the function. Okay, so again, that's using the difference quotient. Alright, so now we're going to notice the shortcut for finding the derivative of the polynomial function. So this is the shortcut that you want to be using for today's homework that is asking you to use a shortcut. Alright, so to find the derivative of the function, so again here we're looking at the same function we saw earlier. Right, the 2x squared plus x. Alright, so here we're going to have an exponent of 1 right here. Alright, so here's the shortcut. To find the derivative of the function, using the shortcut, you're going to take this exponent and you're going to multiply it by the coefficient. So 2 times 2 is 4. Carry over the x. And then this exponent is going to be lessened by 1. So 2 minus 1 is 1. Okay, for the next term, we're going to bring this 1 multiplied down by the coefficient. So it's 1 times 1, which is 1. Alright, bring down the x. Then that coefficient gets reduced by a value of 1. This exponent gets reduced by a value of 1. So 1 minus 1 is 0. Alright, then it's going to simplify. We have x to the 0 is 1. 1 times 1 is 1. So when it's all said and done, this ends up to be 4x plus 1. That is the derivative. And you see, that's the same answer we got over here. Okay, so again, I'll show you that shortcut with this function. To find the derivative of this function, we're going to take the exponent multiplied by the coefficient. So 4 times negative 5 is negative 20. Bring down the x. exponent gets reduced by 1, so that 4 turns into a 3. Next term, it's this exponent multiplied by the coefficient. 2 times 6 is 12. Bring down the x. The exponent gets reduced by 1. Alright? And we go to the constant, well, because, right, there is no variable, right? Again, I could put a variable there, but, right, what's going to happen is this variable has an exponent of 0. 0 times negative 10 is 0, so that goes to 0. So there's nothing left, right, of that term when we use that shortcut. So here is the derivative of that function. Okay. Moving on, example 2 says, quickly find the derivative of each of the following. Okay, so here we're going to find the derivative of this function, the derivative value of this function at 0, 0. Alright, so let's go ahead and first evaluate the function's derivative using the shortcut. So 2 times 3 is 6. Exponent reduces down to 1 minus this one as an exponent gets multiplied. 1 times 1 is 1. But since this exponent is going to get reduced to a 0, x to the 0 is 1. Okay, so there we're left with this is the derivative of the function. Now to evaluate the derivative at 0, I'm going to plug 0 in for x, do the math. There we go. So the derivative of this function at 0 is negative 1. Alright, next example. Let's first find the derivative of the function. 3 times 1 is 3. Exponent gets reduced by 1. Plus 1 times 4 is 4. And since that exponent gets reduced by 1 to a 0, x to the 0 is 1. Okay, so it's 4 times 1, which is 4. Alright, so there's the function's derivative. To evaluate that function at negative 1, plug negative 1 in for x, and we get 7. Okay, so the value of the derivative at negative 1 is 7. Alright, sometimes finding the derivative analytically or even using a shortcut is not convenient. So then that's when we're going to use our graphing calculator. Okay, so in situations like these, right, using the difference quotient or using the shortcut method I just showed you, alright, is not convenient, right? You cannot really use the shortcut for this particular function to find the derivative. Alright, so that's how we're going to use our calculator for this one. Alright, so you're going to press Math, and then you're going to choose option 8, which is the derivative function. Alright, so in for the first blink, the cursor there is going to put the variable x. Inside the parentheses, you're going to type out the functions who you're trying to find the derivative of. Alright, so since it's a rational expression, we got to use fractions here. Alright, so negative x cubed plus 1 over x squared plus 5x plus 7. And then calculator. And arrow over to this box, and that's where we want to put the value of x, where we want to evaluate this function's derivative. And we press enter, and there we go. So the derivative of this function, the value of the derivative of this function at x equals 8 is approximately, so f8 is approximately negative 0.859. Alright, so here we have an exponential function along with a trig function. Again, we'll do the same thing here. So let's go ahead and Math option 8. Alright, so let's do, start again. Alright, so d of x, and here we'll do d of x, negative x, times sine of x. I'm going to double check to make sure my mode is correct. I'm going to hit mode and make sure I'm in radians for this one. I am. Okay, so let's go back here. And here we want to evaluate this derivative at x equals 2. Press enter, and there we go. Alright, so the value of the derivative of this function at 2 is equal to about negative 0.179. Alright, so let's go ahead and finish up with this last example here. It says the surface area of a sphere of a radius r feet is given by, we don't have the function here. Okay, so again, the formula for surface area of a sphere is 4 pi r squared. It says find the instantaneous rate of change of the surface area with respect to a radius at r equals 3. Alright, so again, instantaneous rate of change means derivative. Okay, so let's go ahead and use our shortcut here. Let's just find the function's derivative, first of all. So s of r, we want to find the derivative of s of r using that shortcut. We're going to take this exponent, multiply it by the coefficient. So it's going to be 8 pi r, and that exponent gets reduced by 1. Alright, so now it's just 8 pi r. So to evaluate the instantaneous rate of change of the surface area, an instantaneous rate of change means derivative. Alright, so let's find the function's derivative. We use the shortcut. Now we're going to evaluate it, that derivative at r equals 3. So that means, here we go, the answer is 24 pi. Okay. Alright, so we're going to stop it there for today. If you have any questions, please let me know. You guys have a great day.